Guys, in this video we are going to see an example of power triangle. Now let's look at this given problem. This question is asking, for the following circuit, if device A receives 2 kilowatts at 0.8 power factor lagging, device B receives 3 kVA at 0.4 power factor leading, while device C is inductive and consumes 1 kilowatts and receives 500 VARs, determine the power factors of the entire system. Okay, now in order to do this one we have to use the power triangle. Now let's note down the given informations. For A, we have the P value. P is equal to 2 kilowatts, and also the power factor is provided, that is equal to 0.8. Using this power factor we can calculate the angle. That's going to be cos inverse 0.8, and if you calculate this angle you are going to get 36.86 degree. The angle is positive because they have mentioned this is lagging. If it's leading, it's going to be negative. Okay, and let's look at the given information for B. For B, they have given kVA. That means this is going to be S value apparent, and that's equivalent to 3 kVA. Okay, and also the power factor is provided, that is equivalent to 0.4, but this one is leading. Now we are going to calculate the angle using cos inverse, this is 0.4, cos inverse 0.4, and if you calculate this angle you are going to get 66.42 degree. Since they have mentioned this is leading, this is going to be a negative angle. Okay, and let's look at the given information for C. For C, they have given inductive and consumes 1 kilowatts, so it's going to be P. P is equal to 1 kilowatts and receives 500 VARs. So when they give in VARs, that's going to be Q. Q is equal to 500 and 500 VAR. Okay, now in order to solve this problem we have to calculate all the P value and VAR value. Now let's go ahead and draw the triangle for A and B, because for C we have P and Q value, right? We need these two information, but for A we don't have the Q value. We have to calculate the Q value. For B part we have to calculate both of them. We have to calculate P value and also we have to calculate Q value, because we need PQ value for everything in order to solve this problem. Now let's go ahead and draw this triangle for this one. For the first one, okay, let me draw the triangle here. Here we go. So for the first one they have mentioned this is leading. So for the leading, the triangle should look like this. Okay, so this is for A, and for, okay, this is for lagging. Okay, this is for lagging, and if they say leading, the triangle should look like this. Okay, so this is for B. Now we know the angle, we calculated the angle. For the first one the angle was this one, 36.86 degree, 36.86 degree, and we have the P value. P value should be here. This one is P value, 2 kilowatts, and we have to calculate Q value. Okay, now to calculate Q value you can use the tan theta, because tan is opposite of adjacent. Since we have theta and also we have the adjacent, we can calculate the opposite, right? So tan theta is equal to opposite of adjacent, QA over 2. Therefore QA is going to be 2 tan theta. Tan theta is going to be 36.86 degree, and if you calculate this one you're going to get QA is equal to 1.5 kVAR. So this is our QA value. Now in this one we have the angle provided, that is negative. We calculated the angle, that is negative 66.42 degree, and here we have the S value. S value should be here, that is our hypotenuse, so 3 kVA. We are interested in finding P value and Q value. P value is this one, and let's call this one PB, and this, let's call this one QB. Okay, and we have to find out P value and Q value. We have the angle and opposite side, so we have to do two calculations. Like first we are going to do cos theta. Cos negative 66.42 is going to be adjacent over hypotenuse. In our case adjacent is PB and hypotenuse is 3 kVA. From this one we can calculate PB. If we rearrange this one, that's going to be PB is equal to cos negative 66.42 times 3 kVA, and that's going to give us 1.2 kilowatts. Okay, now we have the PB b value. Now we can find the qb using sine theta, and sine theta, sine negative 66.42 is going to be opposite over hypotenuse. That's going to be qb divided by 3 kVA. Therefore qb is going to be equivalent to 3 kVA multiplied by sine negative 66.42, and that's going to give us negative 2.75 kVA. Okay, actually this one should be in VAR, right? Q value should be in VAR. Okay, so this is our final answer. Now let's go ahead and find our total apparent power. So to find the total apparent, we add all of them, all the P and Q. Here we are going to have PA plus PB plus PC and then plus J. After that we will have QA plus QB plus QC. Now let's go ahead and plug all the values. PA is 2 plus 1.2 plus 1 and plus J, that's going to be 1.5 minus, here we will have minus 2.75 plus 0.5, and that's going to give us 4.2 minus J 0.75 kVA, and finally we will get 4.266 in polar coordinates. That's going to be 4.266 negative 10 degree kVA. Okay, and this is our apparent power. Now we are interested in total power factor, right? So to calculate power factor, we take this angle and find the cos angle for this one. Okay, so power factor is going to be cos negative 10 degree, and if you calculate this one, you are going to get 0.985, and this one is okay. Here we have lagging and leading. This one is negative, cos negative 10. Let me double check this one. Cos negative 10. Okay, we are getting 0.985, but the angle is negative, right? If the angle is negative, it's leading. If the angle is positive, it's lagging. Okay, so that's our final answer. I hope this helps. Thanks for watching.